All right, happy Wednesday. Today we are going to be multiplying and factoring polynomials. Today's lesson is going to be gold notes with some practice, gold notes with some practice. So all the gold notes slides again will be on Google Classroom, so you can copy those down at a later time. All right, let's go. Our first example is 3x squared multiplied by 5x to the fourth power. So when we're multiplying these monomials, we look at the coefficients and we multiply those, and then we look at the variables and we multiply those. Remember, when you multiply the variables, you actually keep the base and you add the exponents. So we're going to be using a rectangle model, the area model for a rectangle, which we know is length times width. And so for when we have a monomial times a monomial, we have just a rectangle, just a single rectangle. So we're going to multiply the 3x squared by 5x to the fourth. So 3 times 5 is 15. And then x squared times x to the fourth is x to the 6. Let's take a look at y. So x squared means x times x. X to the fourth means x times x times x times x. So we put those together, you got 6 x's, right? Exponents are just repeated multiplication of the base. So that's why even though we're multiplying, we actually add the exponents. All right, example 2 on the right, we have 7xy squared multiplied by negative 4x to the third y. So set up my area model with a rectangle, and we're going to go 7 times negative 4 gets us the negative 28. X, there's no exponents. What number is that? That's right, it's 1. X to the first times x to the third is x to the fourth. And then y squared times y to the first is y to the third. So that is multiplying monomials. Let's have you give it a try. Okay, you're going to multiply 3xy squared times negative 6y x to the fourth power. Why don't you give it a try and put in your answer. So 3 times negative 6 is negative 18. X, be careful here. So we can go x times x to the fourth. The order is different, but we need to multiply the x times x to the fourth. So that gives us x to the fifth power. And then y squared times y to the first is y to the third. Let's multiply a monomial times a binomial. So in this instance, we actually need to set up a generic rectangle that's a 1 by 2. So my 1 is for my monomial, the 2x to the third power. And my 2 is for the two terms, my binomial, my 4x squared and my 3y. All right, so we are going to multiply 2x to the third times 4x squared. That gives us 8x to the fifth power. And then this is generic rectangle, so the width here is 2x to the third as well. So 2x to the third times 3y. Well, 2 times the 3 gets us 6. X to the third, there's no x over here, so it's like multiplying by 1. So it's just x to the third. And then there was no y to multiply by, so it's like saying 1 times y, which is the y. So we get 6x to the third y. Here's our final answer, 8x to the fifth plus 6x to the third y. And you're familiar with this from distributive property. Typically, when we're doing distributive property, when we weren't dealing with monomials where we have a variable and a number all the time like this, but same idea. That's what we're doing. But I want you to learn the generic rectangle, the area model, because we're going to be using this for factoring shortly. So, all right, just have you try one. 2x to the third times 3x plus 2y. I set it up for you. Now I want you to do it and type in your answer. So 2x cubed times 3x, well, 2 times 3 is 6. x to the third times x is x to the fourth. And then 2x to the third times 2y, well, the 2 times 2 gets us 4. So it's 4x to the third y. There's going to be your answer. 6x to the fourth plus 4x to the third y. Now we're going to multiply a monomial by a trinomial. So when we do our generic rectangle, we actually need a 1 by 3. 1 for the monomial. So our monomial 2x to the third. There's my monomial. And then we're going to multiply by the trinomial, 4x squared plus 3y minus 6xy. So here's your first term, the 4x squared. Here's your second term, the 3y. Here's your third term, the negative 6xy. So again, each one of these little rectangles, it's an area model, length times width. So our width each time is 2x to the third, and our length, if you will, is the 4x squared is a length, the 3y is a length, the negative 6xy is a length of a rectangle. All right, so 2x to the third times 4x squared, well, 2 times 4 is 8. X to the third times x squared is x to the fifth. 2x to the third times 3y, well, 2 times 3 is 6. X to the third times 1 is x to the third, and then 1 times the y is the y. And then negative 2x to the third times negative 6xy, well, it's going to give us negative 12 x to the fourth y. So then we write out our final answer. We won't leave it in the generic rectangle. We'll write it out. It'll look like that. I have set up the generic rectangle for you on this one. So we're multiplying negative 3x times x squared minus 7x plus 1. Figure out the answer and write it down for me, please. All right, the first rectangle here, negative 3x times x squared, gives us negative 3x cubed. All right, negative 3x times negative 7x, that's going to give me a positive 21x squared. Negative 3x times 1 is negative 3x. So again, you write this outside of the generic rectangle as your answer. It would be negative 3x cubed plus 21x squared minus 3x. Some of you right now at home are thinking, Mr. Plank, I could just do the distributive property. You're right. You could just do the rainbows here and do it this way. That's a perfectly acceptable way to do the multiplication. But again, today I'm trying to teach you how the generic rectangle works because we are going to be using that for our factoring process. So I want you to get comfortable with the generic rectangle. But long run, yes, you may always show me the distributive property with the rainbows. Just make sure you're writing out each part as you did that. All right, main event time. Multiplying binomial times a binomial. So our example is 2x squared plus 1 times 4x minus 3. So this time we have a 2 by 2. So look at our generic rectangle. It's 2 by 2. So there's actually 4 separate rectangles. All right, there's a rectangle here for the 2x squared times the 4x. There's a rectangle for 2x squared times negative 3. There's a rectangle for 1 times 4x, and there's a rectangle for 1 times negative 3. So we do the same process. We multiply all that, and then we write our answer out over here outside of the generic rectangle. So don't just leave it in the generic rectangle. You'll write your answer out separately. You always look for like terms. In this first example, there are no like terms, right? There's x cubed, there's x squared, there's x, and there's a constant. No like terms to combine, but you'll see in the next example, we actually have like terms that we're going to have to combine. So let's move to that example now. 5x minus 4 multiplied by 3x minus 7. So it's a binomial times a binomial. So here's my left side, I put the 5x minus 4. The top of my generic rectangle, I put the 3x minus 7. The order does not matter. I could have put 5x minus 4 on top and 3x minus 7 on the left side. I get the same answer when it's all said and done. All right, so first generic rectangle, upper left box is going to be 5x times 3x. Well, 5 times 3 is 15. X times x is x squared. So that's how we get the 15x squared. Then we multiply, I didn't mean to move that. 5x times negative 7x is the negative 35x. Then 3x times negative 4. Do you see how this 3x is right here? This 3x, for this rectangle, it's the length. So 3x times the negative 4 gets us the negative 12x. And then this last rectangle on the bottom right, this length here is negative 7 units. That's why we call it generic rectangle. You have a negative. Obviously, there's no side lengths, can't be a negative number. It's just a generic rectangle, so we use the area model to organize our math, basically. So negative 7 times negative 4 is positive 28. So this time, we have like terms. Do you see them? That's right. This negative 12x and the negative 35x. So we have to combine those. So we just add them up. So what's negative 35x plus negative 12x? That's right, it's negative 47x. So our final answer is a trinomial. We have 15x squared minus 7x plus 28. What's the Lie coefficient? That's right, Lie coefficient is 15, and the degree is 2, so this is a quadratic trinomial. Let's have you try some now. If you haven't already taken out a piece of paper, I would do so. Write down the generic rectangle here with the 6x minus 5, the 7x plus 9. I would like you to solve this. We'll go through it one box at a time. So first thing I would like you to input is 6x multiplied by 7x. Answer is 42x squared. Now I would like you to do the upper right box, 6x times 9. 54x. Now let's do both of the bottom box. Well, now let's just do the bottom left box, and I want you to input this one at a time in Edpuzzle. So what's the bottom left box going to be? Negative 35x. And finally, the bottom right box. What's the value of that box? Negative 45. Okay, what I want you to do now is I'd like you to combine like terms and write out the polynomial in standard form for me. The answer is 42x squared plus 19x minus 45. Again, we had to combine like terms here, x to the first degree. So negative 54x plus negative 35x is a positive 19x. All right, let's multiply 2x plus 7 multiplied by 4x minus 1. What's going to be our upper left box? We get 8x squared in the upper left box. Now, what's the upper right box? We get negative 2x. What's the bottom left box? 4x times 7 is 28x. What's the final box on the bottom right? 7 times negative 1 is negative 7. Now I'd like you to write out the polynomial in standard form. Make sure you combine like terms. We get 8x squared plus 26x minus 7. How do I get the 26x? Combine the like terms here. The 28x plus negative 2x. So inside the generic rectangle, we just add everything up. That is the answer is the area of the big generic rectangle, if you will. That the 2x plus 7 is one side. The other side is the 4x minus 1. Everything inside that generic rectangle is the answer, is the product of multiplying the 2x plus 7 times the 4x minus 1. So we just combine like terms inside the generic rectangle. Okay, I also want to point out a word. I don't know if you notice. It says expand. So then sometimes you'll see directions on a test, and it won't always say multiply. Sometimes it's going to say expand. So expand means we're going to multiply. Next thing I want you to notice is, you see how we have the parentheses? The parentheses, there's no operation sign between them. When you don't see an operation sign between parentheses, it means multiplication. Why did I bring that up? Every year I teach this class, the first time I give a little quizzy quiz, I mix in some addition, subtraction problems and some multiplication problems. And every year, a student will have a subtraction sign between them or addition sign between them, and the student does multiplication process instead. So you got to realize this means multiplication. It's very important. All right. First one, upper left box. Be careful with this one, a little bit different. What's the answer to the upper left box? So you should have got 12x cubed, or 12x to the third power. Did you get that? That's trickier than before, right? You get x to the second times x to the first. Some of you might have been on autopilot and accidentally put x squared. You gotta be real careful there. So 12x to the third. What's the upper right box? Okay, you should have got 22x squared. What's the bottom left box? 6x times negative 3 is negative 18x. And what's the final box in the bottom right? You get negative 33 when you multiply negative 3 times 11. So I'd like you to write this out now as a polynomial in standard form. Did you notice in this one there were no like terms? So our answer is 12x to the third plus 22x squared minus 18x minus 33. So that's just polynomial with 4 different terms. Ooh, bonus question. Can you tell me what is the lead coefficient for this polynomial? I hope you wrote down 12 as the lead coefficient. Now, can you tell me the degree of this polynomial? The degree is 3. Again, it's the highest exponent for the variable, so x to the third power. This is how we get the degree of the polynomial. All right, we're going to shift gears here, and we're going to talk about factoring now. And we're going to start off with factoring using the greatest common factor. You've done this back in the day in your math classes. So we have, our example is we have a binomial, 20a to the fourth plus 8a. So they did prime factorization of 20a to the fourth here in an example. You see you have 2 times 2 times 5 times a times a times a times a. They did prime factorization of the 8a, which was 2 times 2 times 2 times a. All right, then the pink circles, those are the common factors, right? So it had 1, 2 in common, right? This 2 and this 2. Then it had, it has another 2 in common, this 2 and this 2. And then it has one of the a's in common, just one a. So if we multiply the ones that we circled on the left and the right, 2 times 2 times a, we get our greatest common factor, which is 4a. Okay, so then I have a generic rectangle on the right side to kind of show you this process, because we're not going to do the prime factorization. I just want to show you how this works. So 20a to the fourth plus 8a, I put it inside the generic rectangle. So it's a 1 by 2. All right, so we're starting with everything in the area. We know the area. Now we want to know what are the dimensions of my rectangle. So you start here on the left, and you got to look at 20a to the fourth and 8a and think to yourself, what's the greatest common factor that goes into 20 and 8? So you start with that, and you're going to get, well, I know they both 2 works, but 2 is not the greatest common factor. So then you try 4. Yep, 4 works. So it's 4 times 5, and 4 times 2 is 8. And then you might have thought about 8, but wait a minute. 8 doesn't go into 20. You can't have a decimal or a fraction. You want a whole number. So our greatest common factor from a number standpoint is 4. But wait, we're not done. We have to look at the variables as well. In this case, we only have one variable, a. Well, a to the fourth and a to the first. So the common factor is a to the first, right? Because you can see it here. We circled that was only one a here. There's 4 a's on the left side. So the common is just the 1a. So this side is 4a. All right. So now there's 2 ways to go about this process, whatever your preference is. Some people will go 4a times what? This is the what. And they'll go 4a times what gets me 20a to the fourth. And they go, well, I know 4 times 5. And I know a times a to the third. Okay? And then they're going to go 4a times what gets me 8a. So, okay, I know 4a times 2. And then I don't need an a because it's only a to the first, so 4a times 2. So then my answer is going to be what we got down here, the 4a times 5a cubed plus the 2. Other methods some students prefer is you take the 20a to the fourth, you go 20a to the fourth divided by 4a. That gets you the 5a cubed. And you go 8a divided by 4a gets you the 2. So you can think of it either way. If you don't like the to the what power of doing the multiplication in your head that way, you can divide it out. Basically, 20a to the fourth divided by 4a gets you 5a to the third. 8a divided by 4a gets you 2. Whatever works for you. How can you check your answer? Well, if we multiply this back out, we should get back to where we started from, right? So if I went 4a times 5a to the third, do I get 20a to the fourth? Yep. If I go 4a times the 2, do I get 8a? Yes, I do. So you can always remultiply it to make sure you get back to where you started from, right? It's basically, we're just doing the reverse process of multiplication when we factor it. Okay, on your paper, I want you to factor 21x to the fifth minus 35x squared. I set it up for you in the generic rectangle. That's, again, a 1 by 2. So you got to think about what's the greatest common factor for the number, what's the greatest common factor for the x, the variable. So our greatest common factor for the number for 21 and 35, hopefully you figure that out pretty quick, is going to be 7. Right? 7 times 3 is 21. 7 times 5 is 35. And then for the variable, I put 5x's up top here and 2 here. So my common is just 2 of them. So that's going to be x squared. All right. So now 21x to the fifth divided by 7x squared would be 3x cubed. Or you went 7x squared times what gets you the 21x to the fifth. You went 7 times 3 is 21. X squared times x to the third is x to the fifth. All right, same thing here. Negative 35x squared divided by 7x squared. Well, x squared over x squared becomes a 1, so that basically goes away. It's just a 1. And then negative 35 divided by 7, well, isn't that negative 5? Okay, if you did it the other way, 7x squared times what gets you negative 35x squared? You know that'd be negative 5. So then, how do we write out our final answer? I'd like you to give me the final answer. I hope you told me 7x squared, and in parentheses, the 3x cubed minus 5, close parentheses. So you can see this morning we started, or this evening, or this night, whenever you started this video, we started off by multiplying a monomial times a binomial. Well, here we factored a binomial, and that turned into this monomial times a binomial. So if we were multiplying it, we'd actually start with the 7x squared and the 3x cubed minus 5 outside my generic rectangle to get the inside. When we're factoring it, it's a reverse process, right? It's the 21x to the fifth minus 35x squared inside the generic rectangle, and we're getting the perimeter, the outer portion, to give us the factors. So our factors are 7x squared and 3x cubed minus 5. I want you to factor 36x to the 7th power minus 54x to the 6th. I set up the generic rectangle. I want you to do it on your paper and then write down what is the final answer in factored form for this. This one was a little bit trickier, had a lot of places where you could have fell down, so let's see how you did. So first off, the greatest common factor for the number is going to be 9. So it's 9. I bet you some of you put 6. I'm going to talk about why it's not 6. So it's going to be 9. And then x, well, x to the 7th, that's x times itself 7 times. X to the 6 is 6x's being multiplied. So the common factor is x to the 6th. So 9x to the 6th, that's our GCF. So then 9x to the 6th times what gets you 36x to the 7th? Well, isn't that 4x to the first? And then 9x to the 6th times negative 6 gets you the negative 54 x to the 6. Oh, goody, I made a mistake. Sweet, this is an example I wanted you to see. Perfect. So check this out. I would say my answer is 9x to the 6 multiplied by 4x minus 6. Here I was thinking a lot of you were going to pull out 6 and make a mistake. I pulled out 9 and I made a mistake. So it's not a critical mistake. I want you to see this. So if you pull out the greatest common factor, I should not have any more common factors left inside my binomial. But do you see something that's common in there? Isn't there still a 2? That's right. So I should have pulled out 2 times 9 is 18 was actually the common factor. I didn't see the 18 going into 54 when I did this. So that's fine. For now, I can just pull out the 2's now. And then I would have 18x to the 6 multiplied by 2x minus 3. Do you see how I don't have common factors anymore and how we caught that mistake? That was actually a beautiful mistake. I'm glad I made that. So I'm going to go back through and do this again, do it the correct way. Let's do it the right way. Pull out the greatest common factor, which is actually 18x to the 6th power. All right, 18 times what gets me 36? 2. And x to the 6 times x gets me the x to the 7th. 18x to the 6 times what gets you negative 54x to the 6? 18 times negative 3 is going to get me the negative 54. Then x to the 6 times 1 is x to the 6. So it's just 2x minus 3. So this time I pulled out the greatest common factor. You see how there's less work now? My answer is 18x to the 6th power, then parentheses 2x minus 3. Okay? And so the mistake I made is going to be a common mistake. Sometimes you don't always think of the greatest common factor. So that's why you always need to check your factoring at the end and look at your binomial. Are there any more common factors in there? If there are, you have to pull those out as well and multiply by whatever your factor you had pulled out before by. So that was a good example there. Okay, we're going to factor now a trinomial using the same process, pulling out the greatest common factor. But now you have to pull out the common factor of 3 different terms. So our generic rectangle is a 1 by 3. And we have the 6x to the cube is our first term. Our second term is our negative 4x squared. Our third term is the negative 24x. So this you got to be a little bit more careful because you got to think about all 3 terms. It has to be the greatest common factor of all 3. So let's start with the number. So we have 6, negative 4, and negative 24. So it's even numbers. So I know I can pull out a 2 for sure. 2 can come out. But is that my greatest? I'm not sure yet. Could I pull out a 4? Well, yeah, 4 goes into 24 6 times. But wait a minute. Does 4 work with the 6? No, doesn't work. So in this example, my GCF is going to be 2 for the number. Now, look at the variable. We have x to the first, x squared, x cubed. Let's just go through that again. So x cubed means x times x times x. X squared means x times x. And then x to the first just means x. Right? I can also say times 1 for all those at the end, but you get the idea. So my common factor for all these is x to the first. So we're going to pull out just 2x. All right, here we go. 2x times what gets you 6x to the third? Well, 2 times 3 is 6. X times x squared gets me that. 2x times what gets you negative 4x squared? Negative 2x. And then 2x times what gets you negative 24x? Isn't that negative 12? Okay, and then we write out our answer in factored form, which is 2x, parentheses, 3x squared minus 2x minus 12. Bingo. I set up this first one for you, 6x squared plus 18x minus 24. The generic rectangle set up for you. Do it on your paper. I'd like you to do the factoring, give me the answer. I'm going to give you a warning on this one. It's a little bit different than the example I just did. You notice how the negative 24 does not have an x? There's no x there. So is there going to be a common factor with the variable this time? Your hint is you're only going to be pulling out a number on this one. Give it a shot. So this one, the GCF was actually 6. And so then it should have been 6 times x squared plus 3x minus 4 is your factored form. Now, I'm going to mention this because we are going to be learning how to factor these quadratic trinomials. Sometimes these are factorable. That is not part of today's lesson. But coming soon, we will also look to see if we can factor the x squared plus 3x minus 4, which will actually break into a binomial times a binomial. But stay tuned for that for another day. So for today, this was your answer. 6 times x squared plus 3x minus 4. Our next one is factor 22x to the third minus 11x squared minus 44x. So this one's going to be more like the notes that we did where you need to pull out a greatest common factor that includes a number and a variable. So I'd like you to do this one on paper and give me your answer. All right, let's see if you came up with the greatest common factor. So the number that goes into all those numbers is 11. And then the variable is going to be just x to the first. An easy way to remember with the variable is it's always going to be the lowest exponent. It's going to be what's common between them all, right? Because x to a higher number is going to have that many more x's with being multiplied. So it's always going to be your x to the lowest degree is going to be your greatest common factor. All right, so now 11x multiplied by what gets you 22x to the third? That's right, 2x squared. 11x times what's a negative 11x squared? Wasn't that just negative 1x? And then 11x times what is negative 44x? That would be negative 4. So the answer you should have gave me was 11x parentheses 2x squared minus x minus 4. Just double check your trinomial, make sure we don't have any common factors in there, and we do not. Here's a classic. Someone would forget to pull out the x. They pull out the GCF of 11. Well, then they would have had 2x cubed minus x squared minus 4x. You'd see a variable x in every term. That tells you, whoop, whoop, whoop. Uh-oh, I need to pull out the x. I didn't pull out the greatest common factor. Still need to pull out the x. All right, so you need to get in the habit of always going back and rechecking here if there's any more common factors. Last one, 14x cubed minus 21x squared plus 42x. I want you to factor that using the greatest common factor. Set up for you in a generic rectangle here, 1 by 3. Do it on your paper. Give me the answer. All right, so the greatest common factor for the number, 7 would work. 7 goes into 14, 21, and 42. What about 14? 14 goes into 42 3 times, but not 21. So 7 is our greatest common factor for the number. And the variable, it's going to be x to the first. So we pull out 7x. 7x times what is 14x to the third? Well, that's going to give me 2x squared. 7x times what gets you negative 21x squared? Negative 3x. 7x times what is 42x? That's going to be just 6. All right, so then your answer you should have gave me was 7x parentheses 2x squared minus 3x plus 6. All right, is there any common factors left in the parentheses? No, not a common factor for all 3 terms. So that's your answer for today. And then later on, again, next week, we're looking at can we factor the 2x squared minus 3x plus 6. Sometimes that'll be factorable, so we have to factor some more. But for today, we are good. All right, make sure you've signed up for Khan Academy. I saw a lot more people did sign up. That's great. I want to use it tomorrow's lesson. So tomorrow we're going to be using Khan Academy to practice with polynomials, or adding, subtracting, multiplying, and factoring, just basic GCF. So that'll be on Khan Academy. And then I used Edpuzzle this week, I'm sure you noticed, instead of using Pear Deck. And I want to get a feel for how that worked out for my students. Do you have any preferences? Do you prefer to use Pear Deck versus Edpuzzle or Mr. Plank? It doesn't matter. The reason why I wanted to try Edpuzzle is I got a lot of feedback with different amounts of time students were taking on the Pear Deck slides. And so I feel like I have a better feel for how long it's going to take you when I drive through Edpuzzle. I know the video length, and I can figure out how long it takes you to answer the questions and do that. So I make sure I don't give you too much in a single day. But give me your feedback. Yeah, I like Edpuzzle better. I like Pear Deck better. And it doesn't matter to me. Whatever you want to give me. All right. Thanks, and have a great day. And probably won't see you tomorrow because you'll be on Khan Academy. So have a great weekend, and we'll see you back here on Monday.